All right, folks, so here is a recap on today's lesson over here. This is a very simple concept that we're doing today. Um, we're basically, if I take this out, we're basically trying to find the area in between f and bounded by two functions, in this case, in between f and g, which is this shaded in part. So the thing to keep in mind is that if I consider this green, the area of f, area in between the function f and the x-axis, and the area in orange, which is the of area of g, area bounded between the function g and the x-axis, we can hopefully agree and see that green minus the orange leaves you with the shaded in area. Again, green minus the orange leaves you with the shaded in area. And that is one of the key concepts that we're going to use today. Okay. Now here, okay, we're going to approach this. We want to find basically the area of this yellow right here. Okay, so let me get this out of the way. So what we're going to do, we're going to subdivide this left and right. We're going to find the area of this right here, okay, or the left yellow plus this area in the yellow, and it's going to give us the total. So the area from 0 to 2, we're just going to say, so this left yellow area is going to be represented by this integral right here. From 0 to 2, the area, and this integral represents from 0 to 2 x values, the area bounded between this function, which is y equals to root x, and the x-axis. Okay, so that's the yellow right here. Now, I want you to look at this yellow, pay special attention to this yellow on the right side. Green minus the triangle that is orange will leave you with this yellow right here. Again, let me say that one more time. This green, okay, which is the area bounded between this y equals to the area bounded between the y equals to root x and the x-axis from 2 to 4, which is green, minus the orange will leave you with this yellow. Okay, so green is going to be this right here. Orange is going to be this right here. Okay, it's going to be that right there. Okay, because the equation of this line right here, sorry, it can be a little bit blocked out right here. Okay, because this line right here is y equals to x minus 2. Okay, so again, the orange is going to be the area bounded between y equals to x minus 2, which is this line, and the x-axis is this orange. So green minus orange gives you the yellow, which is what we're interested in. So this right here is yellow on the right. This right here is yellow on the left, and when we add it, we basically get the area of the whole yellow. Okay, and notice again, notice, I'm going to repeat myself one more time, that this is from 0 to 2 x values, okay? And this right here is from 2 to 4 x values, okay? And here is an alternate, and so I'm going to show you an alternate way in a bit. Here is just the algebra associated with it, okay? This is just, there's nothing really special here. We've done this a million times. Root x is, we can rewrite it as x to the power 1/2. At some point when you're evaluating the antiderivative, you're going to run into 4 to the power 3/2. This is going to be 8 because 4 cubed is 64, and the square root of that is 8. Okay. The alternate way of doing this is like this, folks. Orange, we can think of the area from 0 to 4 bounded between root x and the x-axis as this whole orange. Okay, this is, again, that's an alternate way. So orange minus this triangle that is green, okay, will give you the remaining, okay, will give you the remaining area of the yellow. So orange, again, is going to be 0 to 4, bounded between the root x and the x-axis, which is this right here. You can just write root x, okay? This 0 is a little redundant. minus, we can just use our geometric formula of triangle, 1/2 base times height, which is 2 and 2, okay? And then you still get 10 over 3, which is what we got using the other way here, okay? Now, let's look at this right here. Let's look at this example. Oops, let's go like this. Okay, now we are going to, this I really want you to pay attention to, because this is, we're going to do the same thing, but we're going to do it in terms of y, meaning if you look right here, this is in, everything is in terms of x, and then there's also a dx. I should have put a dx right here and a dx over here, okay? So it's written right here. Okay, there's a dx here and a dx. We're going to do these in terms of y next, and that's, I didn't tell you how, or I didn't tell you how, I'm just going to tell you what we're going to be doing. And these right here are all going to be in terms of y in a bit. And I'm going to show you what that visually means. But the first thing I want you to look at over here is, let's take this easy equation over here. I'm going to type it out, y equals to x minus 2. I'm going to just move the 2 over to the other side. And I'm going to x equals to y plus 2. Okay, so let's look here. When y is by itself, everything is we're doing it in terms of x. Okay, look right here. Y is both by itself, and we did it all in terms of x. That's the example we literally just did. But when x is by itself, we're doing it in terms of y. Let me say that one more time. When we isolate x, y, we're doing it in terms of y. Okay, so let's look here and show you what happens, okay, or what that means visually. So the first thing we're going to do is we are going to isolate for x because we're doing it in terms of y. So if you get x by itself, this orange becomes this orange. And if you isolate this for x, this orange becomes that orange. Okay, so again, these oranges on the right side is where x is by itself, and therefore we're doing it in terms of y. Now, what I like to do, this is my own method, okay? What I like to do is reflect this image over the y-axis, so you get something like this, okay? And then what I like to do is turn your head like a confused dog 90 degrees to the left, okay? Which would make this look like, which would literally make this look like, let me copy and paste this. It will make it look like, so if you choose not to rotate your head like a confused dog and just watch this visual here, you're going to end up looking at it like this, okay, if you don't tilt your head. All right. All right. So bear with me. I'm going to go to the next slide. Okay. So now your problem looks like this. And I literally wrote the x equals to y squared that we isolated x for right here. And it's x equals to y plus 2 right here. Okay. And now you can see, now we can just use our same logic earlier. Okay. We are going, I think you would agree with me, I hope you agree with me, that blue, okay, this whole blue minus the, what color can I use? Pink. Let me use blue real quick, is right here. Okay, minus pink, okay, which is this right here, will give you the yellow that's underneath. Remember, the yellow is right here. Okay, so again, blue minus pink will give you yellow. Okay, so I literally do blue minus pink, and we're going from 0 to 2. Okay, and now you just proceed as usual. Now, this is the unofficial way. I have not seen a textbook teach it this way, but because I'm a visual learner, this is how I visualize it. The official way, so if this method that I just showed you works for you, or the other one that I'm going to show you works for you, it doesn't matter. Or you could blend the two. I don't care. Okay, so the way the official way of doing it is, or rationalizing it, I should say, is we used to, okay, when we did it in terms of x, we went from 0 to 4 left to right, okay? That's why in this alternate way over here, okay, in this alternate way, let me see if I can squeeze this in right here. Let's move that, take this, move this, okay? In this alternate way, we went from 0 to 4 left to right, okay? In this, and that's in terms of x. If we do it in terms of y, we're not going from, remember, y is up, down. We're not going from left to right, we're going from bottom to top. And that's why it's 0 to 2, okay? So again, when we're doing it in terms of x, x is horizontal, so we go from left to right, which is 0 to 4, 0 to 4, 0 to 4. But now since we're doing it in terms of y, we're doing it from bottom to top, which is 0 and 2. So 0 and 2, okay? And now instead of subtracting top with bottom, so the old way, okay, whatchamacallit, doing it in terms of x, we would subtract top minus bottom, which is root x minus, here, let me just show you, root x subtract, oh, right here, sorry, root x minus the x minus 2, okay? Now what we're doing is, now the general picture is that we're not subtracting top with bottom, we are subtracting right with left, and therefore it is y plus 2 minus this y plus 2 minus the y squared, okay? So let me just sum it up like this, okay? My way is to reflect this across the y-axis so you get something that looks like this, okay? And then tilt your head like a confused dog 90 degrees to the left, okay? So if your head is, if the top of your head is facing the ceiling, you would now face it to the left right there, and then look at this, which would end up looking like this right here. And then now you just proceed as usual. You would subtract excuse me, I have to sneeze. All right, you would subtract the y plus 2 with the y squared, and you go 0 to 2. Okay, that's kind of a hack. Okay, that's my way of doing it. Okay, now the official way is that you would, instead of going from left to right, now you go from bottom to top, which is going to be your upper lower bound, and you subtract the graph on the right, which is y plus 2, with the graph on the left, which is y squared, okay? So bottom to top, instead of left to right for the lower upper bound, and then instead of subtracting top function from the bottom function, or with the bottom function, rather you subtract the right function with the left from right function with the left function, and hence y plus 2 minus y squared, okay? You can also obviously use your graphing calculator, okay? So I should have said this before we went into example in terms of y. I should have you can just plug this into your calculator right here, okay? X plus 2 minus x squared. Oh, sorry, I misspoke. I meant to say I did it in the correct order actually. So with your graphing calculator, you can literally just put this in, okay? You can just put this into your graphing calculator right here, and just, technically this should be y, but your calculator doesn't know the difference, okay? It's going to give you the same answer no matter what, so you can just go x, okay? All right, folks, hopefully that makes sense. Thank you for tuning in.